Hello everyone, today I will walk you through our project where we built and evaluated a predictive model using the random forest classifier. In addition to achieve high predict performance, we place a strong emphasis on the responsible AI principle, the fairness, and the interpretable. I will explain how our model adhere to these principles through the various explainable AI techniques and the fairness check where the crucial not only for the technical validation but also for the ethical decision making, especially in the high street domain like the financial risk and lending. Our project started with through data understanding and the processing phase. We load the data sets containing the demographic, the health, and the lifestyle information among the various target variable. Stroke occurrence after cleaning and the feature engineering, including encoding categorical variables, scanning numerical features, and creating new feature like the age, the group, BMI categories. We added the class imbalance issue using the smooth tank. This step ensures that this model not become based towards the majority class. Then we developed several models for the interpretability, reliability. We choose the random forest classifier here. The random forest model not only provided robust performance with an average F1 score around 0.96, but also offers the natural feature importance measures that we are valuable for the subsequent interpretable effort. To understand how feature influence predict across the entire data, we first applied the permutation importance in our code after fitting the random forest model and on the resemble training set, we use the permutation importance function on the whole out test set. The result plot shows that the figures such as the age, the BMI, and the average glucose level were most influential. For example, the age not only ranked the highest, but also had clear positive impact on the predicted risk. This global explanation reassures that the model is leverage feature in a way that alien with the domain experts. Next, we use the SHAP for another layer of global and the local interpretability. By the summary, the background data with a k-mean approach, we reduce the computational overhead while still capturing the key patterns. The SHAP summary plots provide a visualization where each dot represents an instance. The axis shows SHAP value, indicating how much the feature pushed the prediction higher or lower relative to the baseline. The color of dots reveals whether the feature value is high or low. For example, you might see that high value of the age and BMI push the prediction towards higher risk, which consistently with our understanding of stroke risk factors. This global view helps the stakeholders quickly grasp which features are driving decisions. While the global explanation provides the all overview, local explanations are equally important to just the individual predictions. To achieve this, we implement two methods. First one is the short decision tree. Okay. We trained a simple decision tree with a maximum depth of 3 to mimic the behavior of our random forest. The Sorogan tree, which is valued as a simple flowchart, offer clear, incredible approximation of the model decision. This helps answer questions like why this particular prediction made, and can be very useful during the regulation audits or the customer inquiries. And another method is LIME. We use the LIME to explain the individual prediction for choosing the test instance. The LIME identifies the top 10 feature in influencing that prediction, displaying both the direction and the magnitude of each figure impact. This level of explanation is crucial when the individual customer or the auditor requests a detailed rationale behind a specific decision. And the next one is fairness. Adding the fairness is cornerstone of responsible AI in our project. We checked for potential bias by the construct demographic feature, the genders from the encoding data. We then grouped the prediction by gender, calculates the mean and the prediction risk. By comparing the predicted positive rates between the male and the female, we compute the fairness metric known as the demonstrative party difference. In our analysis, we found only minimal difference between the group, suggesting that our models not favor one gender over another. While this is promising, the importance to note that fairness evaluation is an iterative process. We plan to extend this analysis to another sensitive attributions, which such as the age groups and the work types to ensure the robust fairness across in the all dimension. When the developing models in an area like financial risk or the leading, the decision made by this model can have the profound real world impact from unfair to opportune. The model might deny credit unfairly or lead the discriminatory pricing. Our approach integrating the multiple XAI technique ensures the transparency and accountability. By using the global explanation, we provide an overall picture of what drives the model prediction. The local explanation further ensures that every individual prediction can be justified and audited. These measures are not just technical nicties. They build the trust with the customer, and the regulation can mitigate legal and the reputational risk. From a business perspective, the implementing XAI in a financial risk model allows the institution to detect and mitigate bias before they cause harm. Explaining the decision is clear, assemble a language which is crucial for maintaining customer trust, enhance risk management practice by identifying the potential model weakness, also ensure the regulatory compliance and reduce the risk of litigation due to the discriminatory practice. So in summary, our project is illustrates how the robust random forest model can be paired with a suit of interpredictability and the fairness technique to adhere to responsible AI principles. From a global explanation like the permutation, importance, and the sharp plots, to local methods like surrogates, decision trees, and limes, our approach provides a comprehensive understanding of model behavior, coupled with fairness metrics and the bias check. This ensures that our model not only perform well, but does so ethically and transparently. Thank you for your attention. So we look forward to any question and discussion on this technique can be further refined in the practical applications such as the financial risk management. Thank you.